Hello, I'm Olivia Yeo, and this presentation is part of the Managing Machine Learning project by Duke University. My project is Recycle.R-AI-ght, a live camera tool that guides Singapore households to sort recyclables correctly. I'll cover 5 areas: opportunity evaluation, DM business understanding, solution validation plan, ML system design. Over the years, Singapore's domestic recycling rate has fallen to about 11%, where roughly 40% of the material in the blue bin end up in contaminated or non-recyclables. The main cause is the sorting complexity. Modern packaging is composite. Spray bottle with HDPE bodies, PP inner layers, and metal springs. Cosmetic jars mix in ABS caps and acrylic PMMA bodies. Takeaway cups made of plastic, paper laminates, PP lids, and craft sleeves. Even though Singapore accepts plastic, especially when it's clean and dry, however, not all Singaporeans can identify them easily. My idea is a mobile tool that uses phone camera to detect material types in real time and give dismantling tips with a traffic light indicator. The opportunities cost high on all 3 criteria taught in the course. Let's define the business problem and a success matrix. In our problem, high contamination and mis-sorting reduces effective recycling yield and raise incineration costs. We are targeting National Environmental Agency in Singapore, municipal recycling operators, as well as Singapore households. Our outcome metrics expected a 10% drop in contamination and pilot blocks, a higher correct sort rate, more recyclable volume captured. We'll also keep a technical output metrics: detection MAP, segmentation MIOU, per material precision recall, and latency under 115 milliseconds per frame on mid-tier phones. The key constraint that we have is the lighting and shadow, mix or damaged material, device camera quality, and user willingness to dismantle. This shapes both model and the UX. Our validation is iterative. Step 1, prototype dataset. Collect diverse household clips and label parts and materials. Step 2, baseline. To start simple, a dominant material classification to establish a flaw. Step 3, to improve, we want to add segmentation and multi-label detection for composites. Augment for glare, low lights, and motion. In step 4, our pilot. Let the user try the ad, and then we compare the prediction with the expert labels, collecting the feedback from the users. In step 5, we did the A/B test in the 2 residential zones, with and without the app, plus weekly bin audits to measure the contamination changed. Earlier on, we can also run a Wizard of Works sections. The users interact with a working UI where our experts supply by the AI's answers behind the scenes. This validates behavior and gathers real input before a full model deployment. In our machine learning system design, we have 4 key trials. Design choice 1, the model type. We will use detection and segmentation to isolate each part. For example, the lid, the sleeve, and the film. Then, a material classifier per part. That matches the granularity the problem demands. Not one label per photo, but per part's intelligence. Choice 2, processing pipeline. A hybrid edge cloud approach. On device for instant guidance and privacy. At the same time, we also have cloud fallback for hard cases or heavier models. This balances latencies and accuracy. Choice 3, data and retraining. A continuous learning loop. Users' corrections feed a retraining queue. We also monitor the precision recall rate and trigger retrace when the KPIs degrade, and every release is versioned with its data. Choice 4, the deployment architecture. A mobile app handles camera and on-device inference. A backend provides model updates, feedback logging, analytics dashboard for NEA to monitor contamination metrics during pilots. Potential risks in production. We might face data and concept drift. This is due to the packaging changes over time. We need to actively learn hard cases and retrain our model monthly. We will also face lighting and image quality issue. We will provide guidance capture, fuse multiple frames, and handle glare low lights. Between latency and accuracy, our lightweight edge models with cloud fallback for low confidence cases. There will be rare cases whereby the items are food soil. The model must have the ability to detect residue and prompt rinse or discards to protect the bin. To ensure pleasant user experience, we must keep the interface simple. We also guard against training serving skills.
The exact pre-processing is packaged once and reused in both training and the phone app with strict input schemas. Before every release, we run a golden set, about 1,000 labeled items, through the full pipeline on both sides, and compare per class metrics and per item outputs. We then do a small canary to watch for any real-world drift before a wider rollout.
To wrap up, Recycle.R-AI-ght applies DM end-to-end clear business goals,
disciplined validation, and a maintainable system design. Our proposal is to run a 2-zone pilot with NEA and municipal operators, instrument weekly bins audits, and track improvements in contamination and correct sorting. Thank you.